All right, so first thing we're going to do, we're going to start our note card together, and this is, what's the date? Tuesday the 2nd. I have a lot of people gone, so I will be recording. We're going to go start and put the last 2 sections on the note card. So I don't know if you like your note card to go in the order that the test is going to go. If so, you might kind of want to block it off into thirds, and we'll put this on the bottom third. If you don't care, because this stuff is on the last third of your test. Does that make sense? So you might want to just put it, you can use one side. So if you want to take a second and break your note card into, go a third of the way down and a third of the way down. We're going to talk about the line stuff, just to review it and get it on your note card. We might get to practicing that stuff a little bit today. Also, if you're watching the video, linked on our slide is the Chapter 3 review, which is required and it's due Friday. The other one is optional for extra credit, and they're both linked in Schoology. All right, so go ahead and put on here lines. And it was sections 3.7 and 3.8, but we're going to put the stuff that you really need to know about lines, okay? And we're going to make it really clear, and we'll go nice and slow. Then actually we're going to go practice some other stuff, but we've been working on these since last Wednesday. So I want to put the 2 forms down. So go ahead and write forms. All right, and the first form is slope intercept, and it's the y-intercept, so if you want to put a little y above there. Maybe below slope, you want to put the variable m, and maybe below y-intercept, you want to put the variable b, and then I'll slow down and let you want your note cards to be really neat. And then maybe below slope, you might want to put how you get it if you don't have it. You know the slope is 3, well then the slope is 3. But if you don't have it given, remember we do y2 minus y1 over x2 minus x1. And then slope-intercept form is y equals mx plus b. Let's circle this and circle that. Those are what you need. Those are numbers that you need. I don't know what you want to write, but that should be enough to trigger you for which one's slope-intercept form. You might want to write yourself underneath here that if not, you have to solve for y. All right, so there's your slope-intercept form of a line, and we also have how you get slope on here. If it were me, I'd either highlight or box those 2 main things in right there. So that's our first form. Our second form, number 2, and I would put a star by it because this is the one you're going to go to if you're not sure which one to use. So if you're like, I don't know which one to use, go to number 2. It's probably the winner. And we're going to write point, slope. And then under the word point, we're going to write x1, y1. Under slope, we're going to write m. And then you're going to go like this. Just in case it's not given to you, you'll walk yourself up to that. It might say the slope of the line is 3. Or it might say it runs parallel to the line 3x plus 1, and you can just steal the slope. But sometimes you're given points and you have to go find it. And remember our form for that is y minus y1 is equal to the slope times x minus x1. Whoops, I forgot the little sub 1 on there. So y minus y1 is equal to the slope times x x minus x1. Remember, these three, so let's go point at it. This guy, and this one at the end are numbers. And let's go above. This guy and this guy are letters or variables. I'm just going to put the word var up there. All right, so those are our two forms of a line. And then I would either box this in or highlight it if you have a highlighter. I'm not going to use my highlighter right now. The only other thing I want to put on there about the lines is parallel and perpendicular. So I'm going to kind of draw myself a little squiggly line right here. And we're going to write parallel lines. Slopes are equal. And you can add to this too. I actually probably would. I'm just giving you the, I want to make sure at least everybody has the skeleton for the last two sections. Perpendicular lines. Flip the slope. And what else? You guys remember? Flip and do the what?
Negative.
Or, yeah, or the opposite. If it is negative, make it positive. So let's go flip and let's say opposite sign. But yeah, you do negate it. And when you negate a negative, you get a positive. So flip and opposite sign. If you need more, you'll know if when you're getting to the practice, maybe at the end of the hour, I'm not quite sure because you're my first hour how far we're going to get in our practice. But if we get to the 3-7, 3-8 formative quiz and you're like, this wasn't enough for you, add to it. Okay? So that's it for making the note card. The next thing we're going to go to is in that chapter review. There's one proof on your test, and we only did 2 in your notes. And we're going to practice these together. You got a page in. We should have all of this done in class. All right, go page in. It's the one with the pink cover. It says chapter 3 review on it. Page till you get to the proofs. And this is what I want you to write. 1, we haven't practiced proofs a ton yet. They're going to be mostly in our next chapter. That's where we get the bulk of them. We talked about the structure of them first chapter. We did some algebra ones, so you got used to identifying properties. You'll have 1 on this chapter's test. If you bomb it, it's not going to fail you. It'd probably be the difference between like an A- and a B or B+. Like it's not going to be huge. Next chapter, though, we need to have them completely down, but we're going to put 1 of these. Not only is there just 1 proof, it's 1 of these 4 that we're going to do. There's 5 on here, but the other teachers told me they're only going to do 4 of them, so I'll do that with you. So 1 of these on test. So if you bomb it on the test, it's 1 of 2 things. Either you weren't listening when I went over today, or you were listening, didn't understand it, and didn't study it. But you should ace the proof, right? It's 1 of the 4 I'm going to do. So by Friday, you might want to look at these again. But we are going to start with, and it's been a while, we did 2 in our notes, but we're going to start with 2 parallel lines up here. Line L is running parallel. You can see the little runners on here to line M. The very first thing we do in any proof is free. You can't get that wrong, and you can't get step 1 wrong, right? What do we write for step 1?
Yes.
Given. We have to get that right. You also have to get the last thing right, because whatever you need to prove goes right here. You don't write proof, though. You have to put the reason for it. So there's 3 things always that are free. First statement, first reason, and last statement. Those are locked in for every proof. The next thing you have to do is say, well, what am I trying to show? So I got to go back up to the picture here. I need to show 4 is congruent to 6. You might say, oh, alternate interior angle theorem. We're proving it. So we can't use it. We're proving why alternate interior are congruent. So we're going to look at this picture and say, for other reasons, what do I know? And I'm going to kind of walk you through this one. I know angle 4 is congruent to angle 2. And go ahead and look at the picture. That's from our chapter 1, What kind of angles are these when they're across from each other on the x?
Vertical.
Vertical angle theorem. Do you remember what you could write vertical angles, but do you remember what I told you could write instead? That. Yeah, vertical angle theorem. Okay. I know 4 is the same as 2. Okay. I also know 6 is the same as 2. You got to go look at the picture because you have to be like, well, what do I know? Well, obviously angle 2 is on here for a reason, right? 4 is the same as 2, and 6 is the same as 2. And I got to look at it. What kind of angles are they?
Corresponding.
Corresponding. And I told you, you could write corresponding angle postulate, but what did I say we can abbreviate that as? CAT. All right, perfect. I can actually now state that 4 is the same as 6. Because if 4 is 2 and 6 is 2, don't you cross those off? Throw 2 out, they're the same. That's a chapter 2 property. Transitive. Yes. Transitive, I like to call it skip the middleman. Like if you're 2 and you're 2, throw 2 out. Boom. Transitive.
Isn't it also law of dispatch?
No, that's a law for like with words of logic. So no, let's write transitive. All right. Now, this one is the converse of the. Yeah.
Couldn't you also get to 4 is congruent to 6 by doing alternate interior?
I already said that at the beginning. That's what we're trying to prove. So we can't use it. It's like in a dictionary. Like if you're looking up the word like proactive and it says proactive, that's not helpful. So if I'm trying to prove the alternate interior angle theorem, I cannot use it. All right? So we're proving these things that we've been told. So let's go take a look at what we're trying to do here. Let's get our lock-ins first. 4 is the same as 6. Okay, I've got my first statement, but if they hadn't given it to me, I'd put it there. My first reason, given. Let's go see if they gave me my last statement. They did. But I'm going to tell you something else you now know. When you're trying to prove lines are parallel, it's always a converse. So you're going to have to think a converse of. Okay? Are we good so far? I don't know what yet because I'm not there. So let's go up here and look at angles 4 and angles 6. All right. Are we ready? Angle 4 is the same as angle 6, correct? Who else is angle 4 the same as? 2. Okay. What's our reason? Vertical angles. Okay. And I think you've got these down, Isaiah. So I think if somebody besides Isaiah, give me the next one. If 4 is the same as 6 and 4 is the same as 2, what allows me to say 6 is the same as 2? Someone besides Isaiah and besides Mark, because he gave me on the last one. What allows me to say, look, if you're 4 and you're 4, throw 4 out. Yep, Alex? Not quite. If they're both equal to 2, why are they, to 4, why are they the same as each other? Not Mark, though. Because you always get this property. Yeah, you got it? Not quite. Nope. If 4 is 6 and 4 is 2, throw 4 out. 6 is the same as 2. We use, yep, go ahead. Transitive. Yep. Transitive. Okay. Now last, we just got these two the same. What kind of angles are they?
Wait.
What kind of angles are they? What are they called?
Wait a second.
Just a, what are those two angles called? 6 and 2. I just got them to be the same. What kind? They're corresponding. Yes, if corresponding angles are the same, the lines are parallel. We would write converse of, but we don't want to write corresponding angle postulate. What do we write? Cap. We write cap. Yes, it is. All right. Now, they should be a little awkward because we haven't done a lot of them, which is why I'm telling you one of these exactly is on your test. We're going to skip this next one because it's almost identical to the one above it. And we're going to go do our next one together. I think I've got, there we go. Our next one together has some stuff given to us and some stuff not. Of the 1, 2, 3, 4, 5, 6 blanks, go fill in 3 of the 6 points are free. Go fill them in. You should be able to get 3 out of 6, even if right now you're like, I'm clueless on proofs. You'll be good at them by the end of chapter 4. Right now you should be, well, I did okay on chapter 1 proof, but they were algebra. In this chapter, you should be okay for the one on the test because it is one of these. Chapter 4, we'll do proofs almost daily, a couple just to make sure you have it down. All right, so 3 blanks should have been filled in for free. Are you ready? This one, what am I going to write? The angle 1 is congruent to angle 7. I have to start the engine. Why? Because they told me. What other blank is going to be for free?
The bottom one.
The bottom one. And you don't write prove in this blank. You've got to figure out, well, why are they the same? All right, so here we go. Are we ready? Are you ready?
Yeah.
Okay, so let's go to the picture because this was not given. And see, now I talked you through the first 2. See if you know why by looking at the picture, this statement can be made. Don't blurt it. Y is 7, 5, and for the same reason, 3 is 1. For the exact same reason. 7 is 5. And angle 3 is angle 1. Go ahead, Sawyer.
I would have to say it's vertical angle.
It is. So now you've got 4 out of the 6. So see how a lot of them are very, 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 very similar. Okay. Now our next one. I've got angle 3 being the same as angle 1. So they're talking about angle 3. And I've got angle 7 the same as angle 1. So throw out angle 1, right? Write it down. See if you know what it is. Why, if they're both the same thing, can I say chuck angle 1, you guys are the same? You should be at 5 out of 6 on this one, just based on the first 2. Somebody besides the people who have contributed. So not Libby, not Sawyer, not Mark, not Isaiah, not Alex. Somebody new. What says we get to throw you out? Go ahead. Yeah, transitive. Excellent. So go ahead and write transitive. All right, so the next one. We've got some transitive. Our goal was to get 3 the same as 5. We'll take a look again. 3 is 7. So you got to start somewhere and say, well, okay, they didn't tell me 3 is 5, but I just showed 3 is 7, right? And 5 is 7. So again, if you're both equal to the same stuff, this is a transitive again. All right, so lots of transitive and lots of that in that one. All right, the last one, and I'll take questions. I'll pause after this one. I'm recording right now. So this last one is going to seem weird in one of the steps and one of the reasons. So this one might be one where you might want to practice it again sometime before what day? Friday. Those other ones, look at them, practice them. Here we go. First of all, though, of the missing blanks, which there's 7, 3 of them are free. Okay, get those points for sure. Last chapter, a couple people left the first reason blank. I'm like, I can't help you. Because what is it always? Given, and what did they give you? That you have a triangle. They're telling you angle ABC up there is a triangle. It should be labeled. Whoever made this, let's label it ABC. All right, they're saying that triangle, that is a triangle. Well, duh, I can see it, but that's what our given is. Step 2 is pretty easy, but it's from chapter 1. So we might have forgotten the wording, but that's where me going over it. You should be, oh yeah, I remember. We're going to go look at angle 1 and angle 4. They have to be supplementary. Because they make a what? A line, right?
Linear.
But do you remember what, yeah, do you remember what we called it? Linear pair, right? So you can write linear pair, or we abbreviated that LPP for linear pair postulate, but that one kids forget, and postulate's a weird word to spell. So I would just say they're a linear pair. That was pretty easy. Also, we have one more for free. We need to prove angle 4 is equal to angle 2 plus angle 3. So really, 1, 2, 3, 4 of the 7. And now the 5th one. I think everyone should, if this was on the other one, I said everyone should get 4 out of 5. On this one, I'd say everyone, even if you struggle with proof, should get 5 out of 7. Free, free, free. Evident from the picture that those make a line. And I think this one's easy too. It's the next 2 steps are a little weird. Because you know what supplementary means. If 2 angles are supplementary, what do? They add up to 180, whoever said that. So you can say, I know the measure of angle 1 because they're supplementary, plus the measure of angle 4 equals 180. So honestly, even though this one looks like the hardest one, of those 7 points, I'm going to repeat. Free, 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 clear from the picture, and we know what supplementary means. It's the next 2 that are a little goofy. Because we proved this, but I think you might have forgotten the name of it. It was on a day when I was gone and you were watching Ed Puzzled Notes. That's why I'm going through these with you. Angle 1, go look at the picture, plus angle 2, plus angle 3 have to add up to 180. And you would say, yeah, because they're in a what? Triangle. But do you remember the name of the theorem?
Triangle postulate.
Almost. Write triangle, because you're like, yep. Don't write they are in a triangle. It's actually called the triangle. And what's another word for adding stuff up? Sum. Yeah, it's called the Triangle Sum Theorem. And if you want to just do THM, that's pretty common in math for theorem. Just write TH. That one is not hard. We all know the angles in a triangle add up to 180, right? We know the angles in a triangle add up to 180. You might want to circle that word and put that in your memory bank, okay? Now, this is the trickiest one. I'm going to start. We've got to figure out what we're going to substitute. Okay, and I'm going to show you. I'm going to get out my highlighter. All right? I'm going to get out my highlighter and go yellow on you so you can see it, because this step's really tricky. That's why I'm doing them with you so you can see it. I am going to take this. You might want to circle it if you don't have a highlighter. And because it says it equals 180, and it says I'm supposed to use the substitution property, I'm going to substitute it in for the 180. Whenever 2 things are equal, you can swap them out. That step I would look at. So let's go take a look at it. I have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals. And I'm going to take 180 out and stuff the stuff that's in for it. Okay, so I'm going to take it out and stuff in the measure of angle 1 plus the measure of angle 4. That was our substitution from last chapter. When 2 things are equal, you get to swap them out. All right, and then the last one's easy. The last reason's easy once I point it out to you. Angle 1 was over here, and it's over here, and all of a sudden it's the only thing that got taken away. How do you think mathematically angle 1 can disappear from both sides? How do you get rid of something on both sides that's positive? Angle 1's gone. You subtract it, exactly. So that's the subtraction property. If you don't see it, you might want to write below here. I'm going to kind of go like this. You might want to write a little minus measure angle 1, minus measure angle 1. So if you're going to study these to make sure you ace the proofs, so that you know what we did. All right, so that's task number 2. Task number 3, we're going to go back a page and we're going to practice so we're kind of all over the place today because we wrapped up the last part of the chapter. I wanted to get some proofs in there because there's